Hello everyone, welcome back to my channel. So today I am here with new chapter climate change. This slide compares climate and weather in a detailed manner. First we will understand climate. Climate is the long-term pattern of weather in a place. It means it describes how the weather usually behaves over a long period of time in a particular locality, region, or even across the whole world. Climate is the statistics of weather, means scientists collect weather data over many years and then study it to find patterns and averages. It is usually studied over a period of 30 years. This long duration is important because it helps us understand what type of weather is normal for that place, not just temporary changes. Climate is measured by observing patterns of variation in different factors. These factors include temperature, which tells us how hot or cold a place is, humidity, how much moisture is in the air, atmospheric pressure, pressure of the air, wind, movement of air, and precipitation, which includes rain, snow, or any form of water falling from the sky. All these are meteorological variables. Here you can also see examples of different climates. One example is a tropical rainforest, which is usually warm and receives a lot of rainfall throughout the year. Another example is an arid desert, which is very dry and receives very little rainfall. These examples help us understand that different regions of the world have different climates. Now let's understand weather. It is the short-term condition of the atmosphere at a specific place and time. It tells us what is happening in the atmosphere right now or in the near future. It includes properties such as temperature, pressure, and moisture. It also includes conditions like sunshine, clouds, rain, wind, storms, and snow. Weather changes very quickly. It can change within a few hours or even minutes. The slide also shows a weather forecast on a mobile phone. This represents how we check weather daily, such as today's temperature or the forecast for the next few days. Now, the most important comparison. Climate is long term, means it describes patterns over many years. Weather is short term, which means it describes condition at a particular time. For example, if we say a place is generally hot and dry, we are talking about climate. If we say today is very hot or it is raining today, we are talking about weather. So you must clearly remember that climate tells us what we expect over a long period, while weather tells us what is happening right now. Alright, now we are going to understand a very important concept, which is climate change. What is climate change, why it happens, and how different organizations define it. First, look at the title, which asks what climate change is. Climate change means a long term change in the usual weather patterns of the earth. It does not refer to small or temporary changes, but to big changes that continue for many years or even decades. Now you can see two main causes or contributors to climate change. The first is natural variability, means that the Earth's climate has always changed naturally over time, even before humans existed in large numbers. For example, the image of a volcanic eruption represents natural causes. When a volcano erupts, it releases ash and gases into the atmosphere, which can affect temperature and weather patterns. Similarly, natural changes like variations in sunlight or ocean currents can also change the climate. The slide also shows a timeline from past to present with different weather symbols. This tells us that climate has always changed slowly over time due to natural reasons. Now, the second cause is human activity. This is very important. The image of factories releasing smoke represents human actions that affects the climate. Activities such as burning fossil fuels like coal, oil, and gas releases gases into the atmosphere. These gases trap heat and lead to warming of the earth. Means that today climate change is not only happening due to natural reasons but also because of human activities. IPCC definition. According to this definition, climate change refers to a large scale and long term shift in the Earth's weather patterns. It is identified by changes in the average conditions such as temperature and rainfall, or changes in how much these conditions vary. These changes last for a long period, usually decades or even longer. So, in simple words, this definition focuses on the fact that climate change is a big and long lasting change in weather patterns. Now, let's look at the UNFCCC definition, that is United Nations Framework for Convention on Climate Change. According to this definition, climate change is a change in climate that is caused directly or indirectly by human activities. These activities change the composition of the atmosphere, and this change is in addition to the natural climate variability that we already discussed. So, in simple words, this definition focuses more on human impact. It clearly says that human actions are a major reason for climate change today. Now we are going to study the evidence of climate change. This is very important because it shows real proof that our planet is warming and that sea levels are rising. Earth is becoming warmer and the seas are getting higher. Let's understand both parts one by one. First, let's talk about global temperature rise. The average surface temperature of the earth has increased, means that if we take the temperature of the whole planet and find the average, it is now higher than before. Since the late 19th century, the temperature has increased by about 0.8 degrees Celsius, which is also about 1.4 degrees Fahrenheit. This may look like a small number, but it is actually a very big change for the entire planet. Even a small increase in average temperature can affect weather patterns, ecosystems, and living organisms. The thermometer shown in the slide represents that the Earth is heating up. The world map with red areas shows that many parts of the Earth are experiencing higher temperatures. For example, places that were once cooler are now becoming warmer, and heat waves are becoming more common. Now let's move to the second part, which is sea level rise. So slide explains that the global sea level has increased by about 20 centimeters, which is about 8 inches over the last 100 years. Means that the level of water in oceans has gone up compared to what it was in the past. It also explains that the speed of sea level rise has increased. During most of the 20th century, sea levels were rising at a rate of about 1.7 millimeters per year. Since 1993, this rate has increased to about 3.4 millimeters per year. Means sea levels are not just rising, but they are rising faster than before. Now you can see the image of the coastal city. It helps us understand this better. It shows how the water level today is higher compared to 100 years ago. Now you may ask why sea levels are rising. One reason is that as the earth gets warmer, ice in glaciers and polar region melts. Another reason is that warmer water expands, which increases the volume of the oceans. So, in summary, we can say that Earth's average temperature is increasing, and at the same time, sea levels are rising and doing so at a faster rate than before. These are strong pieces of evidence that climate change is really happening. Now, let's understand more evidence of climate change. First, we will talk about shrinking ice sheets. Ice sheets are very large areas of ice that cover land, mainly in places like Greenland and Antarctica. The slide shows that these ice sheets are losing mass, which means they are melting and becoming smaller. For example, Greenland lost between 150 to 250 cubic kilometers of ice per year during the early 2000 years. Antarctica also lost a large amount of ice, about 152 cubic kilometers per year during a similar time period. This tells us that a huge amount of ice is disappearing every year. The data mentioned comes from scientific studies which confirm that these losses are significant. Now let's move to declining Arctic sea ice. Arctic sea ice is the ice that floats on the ocean in the Arctic region. This slide compares the past and the present. In the earlier image, there is much more ice, but in the present image, the ice area is clearly smaller. Arctic sea ice is decreasing at a rate of about 13.3% per decade, means that every 10 years a large portion of sea ice is lost compared to earlier levels. This is a strong sign that the earth is getting warmer. Now let's understand glacial retreat. Glaciers are large masses of ice found in mountains. So here you can see a comparison between the past and now. In the past, around the year 1900, the glacier was much larger. In the present, it has moved back and become smaller. This process is called retreat, which means the glacier is shrinking and moving backward. This is happening in many parts of the world, including the Alps, Himalayas, Andes, Rockies. This shows that glacier melting is not limited to one place, but it is happening globally. Now let's move to ocean acidification. How oceans are becoming more acidic. When carbon dioxide from the air enters the ocean, it reacts with seawater and increases acidity. The slide mentions that the acidity of surface ocean water has increased by about 30% since the beginning of the Industrial Revolution, and this increase is mainly due to human emissions, especially from the burning fuels. More acidic oceans can harm marine life, especially organisms like corals, shellfish that depend on stable conditions. Now let's understand that how climate change actually works. This slide explains the greenhouse effect, which is the main reason why the earth is warming. So let's go step by step so you clearly understand the whole process. First, you can see solar radiation coming from the sun. This is the energy that reaches the earth. It is called short wave radiation. This energy travels through space and enters the earth's atmosphere. Now when this solar energy reaches the earth, different thing happens. Some of this incoming radiation is reflected back into the space, means it does not stay on earth, it bounces back from clouds, air particles and even light colored surfaces like ice. The remaining part of the energy is absorbed by the atmosphere and the earth's surface. This absorbed energy warms the land, oceans and air. Now after the earth absorbs this energy, it does not keep it forever. The earth releases this energy back. This outgoing energy is called long wave infrared radiation. Now some of this long wave radiation escapes into space, which help the earth cool down. However, not all of it escapes. Here is where greenhouse gases come into the picture. These gases include carbon dioxide, methane, nitrous oxide, and others present in the atmosphere. These greenhouse gases absorb a large portion of the outgoing heat energy. After absorbing it, they send some of this energy back towards the Earth's surface, and this process is called re-radiation. Because of this, heat gets trapped in the atmosphere instead of escaping into space. As a result, the earth becomes warmer, and this whole process is called the greenhouse effect. It's important to understand that the greenhouse effect is a natural process and it actually helps keep the earth warm enough for life. Without it, the earth would be too cold. But the problem today is that human activities are increasing the amount of greenhouse gases in the atmosphere. Means more heat is getting trapped, which leads to global warming. So, in simple words, energy from the sun comes to Earth, some is reflected, some is absorbed, and then released back. Greenhouse gases trap some of this heat and send it back to Earth, making the planet warmer. And this is how the greenhouse effect works and why it is important in climate change. Alright, so this slide is very interesting because it helps us understand climate by comparing three different planets. The main idea here is that a planet's climate depends on three important things, which are its mass, distance from the sun, and the composition of its atmosphere. So let's understand each planet one by one. First, look at Mars. Mars is smaller in size compared to Earth. Because of its small mass, it can hold a thick atmosphere, means gases easily escape from Mars into space. Since the atmosphere is very thin, it cannot trap heat properly. As a result, Mars becomes very cold. So the average surface temperature on Mars is about minus 50 degrees Celsius. This shows that without a strong atmosphere, a planet cannot retain heat and becomes extremely cold. Now let's look at Earth. Earth has the right size and mass, which helps it hold a stable atmosphere. The atmosphere of Earth is made up of about 78% nitrogen, 21% oxygen, and 1% other gases. This balanced atmosphere plays a very important role in maintaining temperature. Here you can also see two temperature values. Without the natural greenhouse effect, the Earth's average temperature would be around minus 18 degrees Celsius. That would be too cold for most life forms. But because of the natural greenhouse effect, the actual average temperature of Earth is about 16 degrees Celsius. That is suitable for life. So, in Earth's case, the greenhouse effect is helpful and necessary. Now let's look at Venus. Venus has a very thick atmosphere and most of it is made of carbon dioxide, about 96%. Carbon dioxide is a strong greenhouse gas, so it traps a lot of heat. Because of this, the thick atmosphere and strong greenhouse effect, heat cannot escape easily from Venus. As a result, the surface temperature of Venus becomes extremely high, about 460 degrees Celsius. This makes Venus much hotter than Earth, even though it is not the closest planet to the Sun. So the main lesson from this slide is if a planet has too thin atmosphere like Mars, it cannot trap heat and becomes very cold. If a planet has a balanced atmosphere like Earth, it maintains a suitable temperature for life. If a planet has a very thick atmosphere with too many greenhouse gases like Venus, it traps too much heat and becomes extremely hot. So climate depends strongly on the atmosphere and especially on greenhouse gases. This comparison helps us understand why increasing greenhouse gases on Earth can make our planet warmer. Alright, so let's study the greenhouse gases. These are the gases in the atmosphere that trap heat and are responsible for the greenhouse effect. This slide explains some main greenhouse gases and where they come from. First, water vapor. It is the most abundant greenhouse gas in the atmosphere, means it is present in the largest amount compared to other greenhouse gases. It forms naturally from processes like evaporation from oceans, rivers, lakes. An important point mentioned in this slide is that a warmer atmosphere can hold more water vapor. This creates what is called a positive feedback loop. Means, as the earth becomes warmer, more water vapor is added to the atmosphere, which then traps more heat and causes even more warming. So water vapor increases the effect of warming. Now let's move to carbon dioxide. It is one of the most important greenhouse gases. It is released both naturally and through human activities. Natural sources include respiration, which is breathing by living organisms, and volcanic eruptions. Human activities play a major role in increasing carbon dioxide levels. These include burning fossil fuels like coal, oil, and gas, cutting down forests, and changing land use. For example, when cars release smoke or factories burn fuel, they add carbon dioxide to the atmosphere. This increases heat trapping. Methane, it is another greenhouse gas that is very effective at trapping heat. It is produced from both natural sources and human activities. Natural sources include the decomposition of organic matter. Human related sources include waste in landfills, agriculture, especially rice farming, livestock like cows. For example, cows release methane during digestion, and waste dumps also produce methane as materials break down. Even though methane is present in smaller amounts than carbon dioxide, it is very powerful in trapping heat. Nitrous oxide, it is also a strong greenhouse gas. It is mainly produced through human activities such as farming practices, especially the use of fertilizers. It is also released during the burning of fossil fuels, production of certain chemicals, and burning of biomass. For example, when farmers use fertilizers in large amounts, it can lead to the release of nitrous oxide into the atmosphere. So there are several greenhouse gases in the atmosphere, and each one plays a role in trapping heat. Water vapor is the most abundant, carbon dioxide is the most discussed because human activities are increasing it rapidly. Methane and nitrous oxide are also very powerful, even if they are present in smaller amounts. All these gases together increase the greenhouse effect and lead to global warming. So, controlling the amount of these gases is very important to reduce climate change. Here are some other important gases that also affect climate. These gases are not the main ones we studied earlier, but they still play a significant role. First, we will talk about chlorofluorocarbons, also called CFCs. They are different from other gases because they do not have natural sources, means they are not produced naturally in the environment. They are completely man made. They were created and used for purposes such as refrigeration, aerosol sprays, cleaning solvents. For example, they were used in refrigerators and spray cans. Global effort was made to stop their production, and this effort started around the year 1928 and was very successful. However, there is an important point here. Even though production was reduced or stopped, CFCs remain in the atmosphere for a very long time. Their atmospheric lifetime is more than 100 years. This means they continue to affect the environment long after they are released. That's why they are still a concern today. Tropospheric ozone. Ozone is a gas, and in this case, we are talking about ozone present in the troposphere, which is the lowest layer of the atmosphere where we live. The tropospheric ozone is the third most important greenhouse gas after carbon dioxide and methane. It also mentions that its concentration has increased by about 30% since the pre-industrial era. This shows that human activities have increased its amount in the atmosphere. Additionally, between the years 1979 and 2014, the global amount of ozone in the troposphere increased by about 3%. This increase contributes to warming because ozone can trap heat in the atmosphere. CFCs are man-made gases with no natural source, and even though we have reduced their use, they remain in the atmosphere for a very long time and continue to affect climate. Tropospheric ozone is another important greenhouse gas that has increased over time due to human activities and contributes to global warming. So, along with the main greenhouse gases, These gases also play a role in climate change and must be controlled. Now we are looking at a very strong evidence of climate change. This slide shows the unmistakable rise of carbon dioxide in the atmosphere. First, look at the graph on the left side. This graph shows carbon dioxide concentration over time. The horizontal axis represents year starting from around 1958 up to recent years, and the vertical axis represents the amount of carbon dioxide in the atmosphere measured in parts per million. As we move from left to right, we can clearly see that the line is going upward, means carbon dioxide levels are increasing continuously over time. You may also notice a zigzag pattern in the graph. This up and down pattern happens due to seasonal changes, such as plants absorbing carbon dioxide during some parts of the year and releasing it during the other. But even with these small ups and downs, the overall trend is clearly increasing. Now let's understand the numbers given on the right side. In the year 1750, which is before the industrial period, the level of carbon dioxide was about 280 parts per million. Today it has increased to more than 407 parts per million. This is nearly 40% higher than pre-industrial levels. This is a very large increase, and it has happened mainly because of human activities such as burning fossil fuels, deforestation, and industrial processes. The slide also mentions that the first continuous and precise measurement of carbon dioxide began in 1957 at a place called Mauna Loa in Hawaii. It is important because it shows that scientists have been carefully tracking carbon dioxide levels for many years using reliable data. The image of the observatory represents this measurement station where scientists monitor atmospheric gases. So this slide shows what has been happening over a very long time, about 800,000 years. First, read the main statement on the slide. It says that historical measurements show that the current levels of carbon dioxide, methane, and nitrous oxides are unprecedented compared to the past 800,000 years. The word unprecedented means something that has never happened before. So, this statement is telling us that today's level of these gases are higher than at any time in the last 800,000 years. Now what the graph shows, there are three graphs, one for carbon dioxide, one for methane, and one for nitrous oxide. Each graph shows how the concentration of these gases has changed over a very long period of time, starting from about 800,000 years ago up to the present day. If you look at the earlier part of the graphs, you will notice that these lines go up and down repeatedly, means that in the past the levels of these gases changed naturally over time. These changes were gradual and followed a pattern. For example, during colder periods the levels were lower, and during warmer periods the levels were higher. But even then the changes stayed within a certain range. Now look at the present day part of the graph, which is highlighted. You will see a sudden and sharp increase. This is called a spike. This spike is different from the earlier pattern. In the past, changes were slow and gradual, but now the increase is very rapid. This sudden rise is seen in all the three gases, carbon dioxide, methane, and nitrous oxide. This tells us something very important. Natural changes alone cannot explain such a rapid increase. This sharp rise is mainly due to human activities such as burning fossil fuels, agriculture, and industrial processes. Let's understand an important concept, global warming potential. You know that not all the greenhouse gases are equal. Some gases trap much more heat than others. So let's understand this clearly. First, what is global warming potential? It is a way to measure how much heat a gas can trap in the atmosphere over a certain period of time. And this time period can be 20 years, 100 years, or even 500 years. To make comparison easier, carbon dioxide is given a value of 1. This means all other gases are compared with carbon dioxide. Now let's understand the example given. In slide you can see that over a period of 20 years, methane has a global warming potential of 72. This means that if we release the same amount of methane and carbon dioxide into the atmosphere, methane will trap 72 times more heat than carbon dioxide over those 20 years. This shows that methane is much more powerful than carbon dioxide in trapping heat, even if it is present in smaller amounts. Now look at the comparison. The image with the balance shows a small amount of carbon dioxide on one side and many blocks of methane on the other side. This is to show that methane has a much stronger effect per unit than carbon dioxide. Now let's move on to the table on the right side, which shows global warming potential over 100 years. Carbon dioxide has a value of 1, which is our reference. Methane has a value of 28, means methane traps 28 times more heat than carbon dioxide over 100 years. Nitrous oxide has a value of 265, means it is even more powerful. CFCs 11 have a value of 4660. This is extremely high. HFC 23 have a value of 12,400, which is even higher. Sulfur hexafluoride has the highest value shown, about 23,500, means it is extremely powerful in trapping heat. So what's the main idea? Different greenhouse gases have different abilities to trap heat. Some gases, even in small amounts, can have a very large impact on global warming. So it is not only the amount of gas that matters, but also how powerful that gas is. This is why scientists study global warming potential, so that they can understand which gases are more dangerous and needs more control. Now let's understand the impacts of climate change on our world, that what is already happening around us as a result of climate change. So the statement at the top says that effects which scientists predicted earlier are now actually happening. These includes loss of sea ice, faster sea level rise, longer and more intense heat waves. Means climate change is no longer just a theory, it is clearly visible in real life. So let's understand each impact one by one. First, melting of snow and ice. Due to rising temperatures, ice in glaciers, polar regions, and mountains is melting. This reduces the amount of ice on Earth. When ice melts, it also contributes to rising sea levels. This is one of the clearest signs of global warming. Ocean acidification. As we studied earlier, more carbon dioxide is entering the oceans, which makes ocean water more acidic, and this harms marine life such as corals and shellfish. Coral reefs, which are very important ecosystems, are getting damaged because of this. Changed precipitation. Precipitation means rainfall, snowfall. So climate change is disturbing normal patterns of rainfall. Some places are getting too much rain, leading to floods, while other places are getting very little rain, leading to droughts. This imbalance also affects agriculture and water supply. Sea level rise. As ice melts and ocean water expands due to warming, sea levels are increasing. This causes flooding in coastal areas. Cities near the sea are at risk, and people living there may face serious problems. Extreme weather patterns. Climate change is causing more intense and frequent extreme weather events. These include stronger storms, heat waves, wildfires, heavy rainfall. These events can damage property, harm people, and affect the environment. Ecosystem impacts. Ecosystems include all the living organisms and their environment. Climate change is disturbing these systems. Animals and plants are losing their habitats. For example, polar bears are losing sea ice, which they depend on for survival. Many species may struggle to adapt or may even become extinct. So, climate change is affecting many parts of our world. It is melting ice, rising sea levels, changing rainfall patterns, increasing extreme weather events, and harming ecosystems. All right, now we are going to understand how we can respond to climate change. This slide explains two very important approaches, which are mitigation and adaptation. Both are necessary and we must understand the difference clearly. First, let's understand mitigation. Mitigation means reducing the cause of climate change. In simple words, it means we try to reduce the amount of greenhouse gases into the atmosphere. The slide explains that this involves reducing emissions and stabilizing the levels of heat trapping gases, and this can be done in two main ways. One way is to reduce the sources of these gases. For example, we can reduce the burning of fossil fuels for electricity, transport, and heating. Using renewable energy like solar and wind power is a good example of this. The second way is to increase what are called sinks. These are natural systems that absorb and store greenhouse gases. For example, it includes forests, oceans, and soil. Planting more trees helps because trees absorb carbon dioxide. So mitigation is all about stopping the problem from getting worse. Now let's understand the flow shown in the middle of the slide. If there is less mitigation, it means more greenhouse gases are produced. This leads to more serious climate change effects. As a result, there will be greater impacts on human and the natural environment. Because of this, more adaptation will be required. On the other hand, if there is more mitigation, fewer greenhouse gases are produced. This leads to less serious climate change effects. The impacts on humans and nature are smaller and therefore less adaptation is needed. This clearly shows that mitigation can reduce future problems. Now let's understand adaptation. Adaptation means managing the effects of climate change that are already happening or expected in the future. The slide explains that adaptation involves adjusting to the changing climate. The goal is to reduce our vulnerability to harmful effects. For example, if sea levels are rising, people can build stronger sea walls or raise buildings to protect from flooding. If extreme weather becomes more common, better disaster planning can help. In agriculture, farmers may grow crops that can survive in new climate conditions. So, adaptation is about learning to live with the changes and protecting ourselves. So, what is the main concept here? It is mitigation tries to reduce the causes of climate change, while adaptation tries to manage the effects. Both are important. If we do more mitigation, we reduce future damage. If we do good adaptation, we can handle the changes that are already happening. So, to deal with climate change effectively, we need both mitigation and adaptation working together. Now, let's understand the global efforts to deal with climate change. Now, this slide shows important international agreements and how countries around the world have worked together over time. First, the slide shows a timeline with three important years: 1992, 1997, and 2012. These represent key events in global climate action. Let's start with the year 1992. In this year, an important meeting called the Earth Summit was held in Rio de Janeiro. This was officially known as the United Nations Conference on Environment and Development, and this meeting was very important because it brought countries together to discuss environmental problems, including climate change. As a result of this summit, three major agreements were created, and these are the United Nations Framework Convention on Climate Change, United Nations Convention to Combat desertification, and the Convention on Biological Diversity. Among these, the United Nations Framework Convention on Climate Change is very important for climate change. Now let's understand what this convention aims to. Its main goal is to stabilize greenhouse gas concentrations in the atmosphere at a level that prevents dangerous human interference with the climate system. In simple words, it aims to keep greenhouse gases under control so that climate change does not become harmful. Now let's move to the year 1997. In this year, the Kyoto Protocol was introduced. This was an international agreement connected to the United Nations Framework Convention on Climate Change. And main goal of the Kyoto Protocol was to reduce the overall emissions of six important greenhouse gases. This agreement was important because it set targets for countries to limit their emissions. Now let's move to the year 2012. In this year, the Doha Amendment was introduced. This was an update to the Kyoto Protocol. It established a second commitment period, which means countries agreed to continue working on reducing emissions for another period of time. So the main message of this slide is climate change is a global problem, so it requires a global response, and countries around the world have come together through meeting and agreements to reduce greenhouse gas emissions and protect the environment. The Earth Summit started this process, the Kyoto Protocol set specific targets, and the Doha Amendment continued those efforts. So this slide shows that international cooperation is very important in solving climate change.